Welcome back to a new PrivKey webinar. We haven't done one quite some time, but I'm ready for another one. And this one is specifically on the topic of Web5, or this new terminology, basically meaning the Decentralized Web Platform. This is all a new evolution of the web that enables decentralized apps and protocols. Again, my name is William Santiago, and I'm glad that you're here to take a look at this webinar. So let's get started. The evolution of the web basically has started quite some time, and today what we have is a model that people are users who do not own their data or identity, and that's basically what we're at the moment facing, right? They're given accounts by companies, and their data is held captive in these what they call app or data silos. You'll have Yahoo, you'll have Google, you'll have Microsoft, and all sorts of centralized databases that keep your data. With the hacking and breaches that happen on an ongoing basis, on a weekly basis, monthly basis, etc., your data is just not safe. So the other option is just encrypt it and put it up in these silos, right? So the idea behind this Web 5.0 is that we want to be able to bring that data back and control back to the user. It's basically to create a new class of decentralized applications and protocols. In the case of Block, which they're taking the initiative, is called TB, Decentralized Exchange of Information or Data. It puts the individual at the center and empowering them with self-owned identity and restore control over their data. So you'll have your financial information, your personal, social, all of that will be somehow in control of the user. Not to say that it's going to be in one location like picture depicts, but the control at least is one entity. So what does Web 2 equals Web 3? You know, that's basically, we looked at Web 2.0 and we looked at Web 3.0, which is what the buzz has been, what's been said in Twitter and social media. This craze about Web 3.0 because of this new decentralized exchanges and CeFi and DeFi. So Web 2.0 is basically, or Web 5.0 is basically a combination of Web 2 and 3 together. This is a decentralized web platform, enables developers to write decentralized web apps. These are all acronyms: DWP, DWA, Decentralized Identifiers, DIDs, Decentralized Web Nodes, DWNs, returns the ownership back and control to the individual. That's what Web 5.0 is trying to do. It comes from Web HTML5. Some of us remember that we've seen out developers, especially front-end developers, have seen what we call HTML5. It's a conglomerate of voice, data, and sound, video, voice, data, sound, and everything go put together in one standard, instead of having multiple standards and multiple apps and multiple libraries, etc. So we try to, let's code one way and we send both data and video. This is very similar to the beginning of the internet, or the beginning of displaying sound and voice on the internet, or on presentations or anything that was digital. You had these cables that had different standards. You know, HDMI is kind of like took all of these cabling standards. You had multiple cables, everything into one cable called HDMI. So this is basically the same idea. Now there's certain pillars of Web 5.0. There's the decentralized identifiers, what I call the DIDs. These are standards that are being developed right now. It's self-owned identifiers that enable decentralized identity authentication anchored routing. So basically you have some anchoring, and that says, okay, this is the originator of that identity, and it's being routed through this decentralized network. So that's the first pillar. The second pillar is the verifiable credentials. These are data formats and models of cryptographic presentation. Basically, the way you verify claims. We've been using this already for a long time for domains, credentials. Basically, you certify, and somebody or some entity out on the web has your public key, for example, of a specific domain that you control, and you can verify that, prove that you are the owner of that certificate. And finally, something that has not been standardized, and we hope that this will start the process, it's what we call decentralized web nodes. It's a personal apps, data storage, and message relay nodes that serve as the foundation for decentralized apps and protocols, basically. So let's look a little bit deeper into what pillar number one is, which is the DIDs, Decentralized Identifiers. So what you have here is just an example of Bob. He can basically discover the IDs indexed in the network to independently resolve and verify them. So here's Bob. He's going out to this blockchain or the distributed network, and he's just looking at the IDs basically. So Alice then self-generates her own DID and anchors, basically anchors the data or state changes in that network, in that blockchain, and puts it there. So then Bob can basically look at what she self-generated, right? Now, what features does this bring is basically brings the identifiers are self-generated and self-owned, meaning that Alice, in this case, she's generating that identity. She can prove who she is, who she actually is, and she can put those credentials out there. At least a public key is generated, and Alice controls it. There's no centralized providers or trusted authorities, so that's another feature of this having the decentralized, because it's all distributed throughout the network. There's no special utility tokens or subjective consensus. We don't have to worry about another token. We talk about all these different blockchains that have their own tokens. That's not the case here. It's highly resistant to all forms of interdiction, and finally, so it's resistance to that type of let's say, erasure of your own identity. IDs can be made universally discoverable. So this is the last part of this feature. These features that DID has is that the ability for Bob to find Alice, or actually check who Alice is, very, very easy and in a distributed way that's always available, super redundant, etc. The second pillar of this verifiable credentials is basically this example that we talked about. It says, let's say that we have a bank, right? We call this Acme Bank, ID verification, IDV, it's an issuer. They're the bank that issues these. They anchor these IDs because most of these banks have already a lot of identity of different users, basically their customers, right? So they anchor issuers' DID to the public key and endpoints into in this case ION, but it could be rootstock or login, which the infrastructure is RIF. It's called RIF. So this is basically you're anchoring this into the blockchain using different protocols, like for example Sidetree, etc. So the point is here that the bank is now the one authorized to put these credentials in there on behalf of the users, right? Now what happens is that the issuance of the verifiable credential is basically the user is able to grab that DID that they have. So this transfer of, say, okay, now we've created we've anchored the information into the blockchain. Now we're handed it over to the user. So the user now gets the account, the name, and issues that digital signatures over. So it's kind of like ownership goes to the owner. The IDV, the issuer, basically is, okay, I'm out of here. And this is a type of a trust relationship here, but the idea is that I can prove that this is the actual credential. I'm handing it over to the actual user. This is usually a manual process. So from that point on, the user can present that account proof, saying that I have an account on this bank, on this issuer, and this is my title, this is my name, and then you get digital signatures that the user, so this becomes personal financial information. So what happens is that when this is given to some entity out there, they can go back down to the blockchain and verify that that user is who they say they are based on that signature. Because the PFI, or the personal financial information, is just a public key. The public key goes to the user, and the user then to that user that's specifically looking to see if that person is who they are, and they verify on the blockchain. Now you move into the pillar number 3, which is the features that you have for decentralized web nodes, right? So what do you get when you have all these different nodes all over the place? You have this universal addressable, kind of like crawlable, basically, DID, relative addressing data. And this is usually the idea that you can Google things. You can type in the Google bar, Google search, and search for anything you want. So this is the same idea, trying to create these nodes that will have all this data handy for everybody to use. Because this data is in multiple nodes all over the internet, it gets replicated. So there's no master controlling this. There's no centralized database. Everything is replicated throughout devices on the cloud. It's very secure because you have the default is encrypted with the individual keys. That same individual is encrypting the data as they put it out on this blockchain. There is semantic discovery, so meaning that there's a human language involvement, meaning that the users can basically type Alice or type Bob, and they will be able to get to that original, or at least get on the blockchain, say, who is Bob, and can you prove it to me? And this could be done with a very simple app, with a QR code, etc., etc. So it's a human language involved. You also have a built-in encrypted send and receive messages over this DID network. So you want to communicate, since you are most of the time not at the same location and you're remote on this shareable internet, you can then, besides proving yourself, that you can sign these messages, and you can prove that you are talking to the person or the entity that you're actually talking to. So there's no need for a camera, there's no need for all these other legacy 2 type of verifying abilities out there. You also have support any type identity type. So it doesn't mean the identity means to a user, to a person, to a human. This could be to Internet of Things. It could be a house. It could be a car. It could be a door, multiple doors. It could be a camera. It could be all kinds of things that can intelligently do this. Let's say human identity, but they do it at the device level. So decentralized web nodes is an emerging standard. So we don't have one at the moment. For data storage and relay that enables entities of any type, people, organization, etc. And you send and store encrypted public messages, just as we talked about, enabling a wide variety of decentralized apps and protocols to be built on top of this decentralized nodes pillar. So let's look at the anatomy, the parts, the components of this identity wallet that we're kind of like building this identity wallet. So at the center of the whole thing is the user with their device, their wallet, and that has a private key inside that device. This allows for the user to have data management, provide a user interface and functionality to manage credentials and apps that store these DWNs, right? It also has the ability for credential functions. You can sign, you can verify, you can discover, you can present credentials to verify these parties. So you have that other function. You can also have, you also, by default, you have the DID authorization. So you perform authentication and authorization if needed to manage these type of authorizations. You authenticate yourself. So that's the first step. You authenticate and provide, what can you, based on that authentication, what can you perform, and can you read that data, and what data needs to be read. So simple things like, when you see a license, you don't have to provide the person who's looking at your license, they don't really have to see everything in all the details in the license, like the address and your country of origin, et cetera, et cetera. This could be a bartender. He only needs to know, not even the year you were born. He just needs to know, are you of age to be able to drink. You also have DID functions. These are basically different types of methods: create, update, and recovery any DID. So if you lose your phone, if you have to change your name, and there's kind of things that you have to change your passport, you get a new citizenship, all these things. The app or the application and the framework has to be able to handle that. So these are basically functions of this. And finally, you have contact management, which basically maintains and enforces which DIDs are used with different people and apps. So this is similar to DID authentication, but in this case, it's what we talked about, the bartender talking to the, wanting to see your identity and only want to know if you're above age or not. So what's permitted, right? What can be seen or not? So now, just to step away and look at the actual topology, what does this mean? How does it work? So in this example, you have Alice has her own remote set of nodes, right? And Bob also has his set of nodes, and they also consider their mobile phone, in the case of Alice, is another node. Bob's local PC at home has his own local node there participating, right? And in the center, you have this connecting distributed ledger that we call blockchain. So what happens is the first step is that Alice sends a request to the blockchain, basically saying, who is Bob? I want to see the Bob's digital ID. So it's like, show me your license, right? So Alice sends that message to Bob's network, right? Somehow it gets there. She doesn't need to know how that happens. She just says, I want to see Bob. So it's like searching you don't care what the search engine does. You just care about getting a result on your question. So what Bob's distributed network does, or set of nodes, is it says Bob relays the message down to Bob, to the actual Bob, maybe the actual node that Bob is working on. And Bob basically Bob resolves Alice DID. So that request that Alice did using the blockchain, it's kind of like a peer-to-peer between them at that moment. They exchange kind of like a public key. So Alice was looking, okay, who's this Bob? And then Bob sends Alice, here's my public key, and we can continue, and I'll get your public key, and then we can continue the conversation, right? So Bob sends the same response back to Alice on her node. So she received that message itself, and now they're kind of like encrypted information between just Bob and Alice. There's no third party at the moment. And so Alice then relays that response that she got, that public key and everything, relays it to her own network. So her network is aware now of all these, of who's Bob, basically. She said she had verified Bob. So this combination of decentralized identifiers and decentralized web nodes produces a web of DID secure messaging, data sharing, and centralized and credential exchange. So all of these things can happen because you have exchanged these public verification between the two of you. One of the protocols is encrypted messaging, photo sharing, etc., universal standards, all types of semantic data exchange. So from this basic identity solution, you can basically create all these apps on top. So let's visualize the Web5 and the DWP, the stack that it has. So you start at the decentralized identifier. So that's the first step, is decentralized identifiers or DIDs. You have that in your base. From that, you move into decentralized web nodes. You have these distributed web nodes, and that builds on top of this DID. And then on top of these nodes, run these DW platform, the DWA platform. And this platform basically runs all the apps on top. So it's the foundation for all the apps, decentralized web apps, that open source projects that could be, be started once this whole setup is. So you're building this foundation, this stack, to have this model be able to be visualized, right, or created. So what are PWAs? PWA stands for Progressive Web Apps. So these are web apps, whether on your phone or your PC or your, doesn't matter. There's just web apps, reactive web apps, basically. And they will be running on all kinds of browsers. So we're used to using browsers. Browser is going to become the center focal point where these apps will be running. So there are websites that took vitamins and have special power. Let's put it that way. And you see it with Facebook. You see it with Google web pages. You know, some of these pages they have different windows and different videos and things all over the place in that one, whether it's your mobile phone or they're very self-reactive. They know you're reviewing certain apps from the phone or from the browser. So what they bring to the table is these apps is progressive, so they can scale very well. They're responsive. We talked about it knows that you're on a phone, or it knows you're on a tablet, or it knows that you're on a big screen, for example. It can work offline, so you can be disconnected from the internet and the application will still function. It's app-like, so it feels whether you're on a desktop or not. It's mobile-centric feeling kind of thing. It's fresh, meaning that it's constantly being updated. So you don't have to, let's say, run an update and upgrade a certain version. You know, it's actually self-refreshing basically. It's safe because it's constantly encrypted from the source. So once the data leaves the app, it's just encrypted basically. It's discoverable because now you have a web portal, and just similar to the Google search engines basically, or the search bars. You can it's re-engageable, meaning that there's messaging talking to between all these apps. So most apps will be, or most of these apps will be talking to each other and exchanging information in the back end to facilitate all these features basically. It's installable because now you can install it on all these devices in a very easy way. It's almost like going to the website. You don't have to install a Facebook app, for example, React app. You just got to go to the web page, and the app will be there for you to work. So it's kind of like installable already, and it's all linkable. All these apps will talk to each other just to be able to regenerate, re-engage with each other and with other users and with other devices, IoT, etc., etc. So we move from PWAs to DWAs. So now we're moving from progressive web apps. These are the types of web apps, Web 3.0, where you have a web app that has some service and that it sends over to local cache on your phone or on your computer, and then it sends also data to a centralized app server. This is the typical Facebook page, basically, where it does all these things, but they're doing them in local cache or on a centralized server. Now we move to decentralized web apps, and these web apps now have some kind of special software, SDK, and that software now has a service worker just like the Web 3.0, but now this software on your web app is encrypting all this stuff using these private, certificate, private keys, etc., and it's sending that, keeping that in local cache, just to make sure that if we do disconnect from the internet, it's the functionality is still there. But now the difference is that instead of sending it to a centralized app server, now you decentralize web nodes, whether you control it or you have a third party control them for you. But the point is that now you're sending you're not dependent on a specific entity, company, or government to house and secure your data. Whether that data is already secured by you, but you might not have access to the data because maybe their service goes down, etc. For example, if Amazon goes down, be a disaster, but that possibility. This eliminates that factor. So this is what we call Web 5.0. So let's give an example of a bank transaction or a bank engagement with a bank, basically. So here we have three players. You have the actual blockchain, the distributed ledger. You have Alice again with her ownership of her identity, and then you have a bank that participates in this network as well. So they're connected to this distributed decentralized web of nodes. So what happens is that Alice sends a resolve to the bank, similar to what she was doing with Bob. Now she's doing it to the bank. Is this bank the actual bank that I need to talk to? So it goes and searches for the DID of the bank. Alice fetches credentials from the bank DWeb basically node based on a schema. So this is it's code related, but this is something developers would code in to their apps, and they would go from the web page, that web app, basically grabbing and fetching the credentials of the bank. So there's many activities in our world that require the establishment of trust between participants. So what happens at DIDs and DWebs nodes allow individuals, organizations, and companies to publish credentials that anyone can basically discover independently verify. So by going to that bank and getting there, kind of like the public node by that very simple code exchange, that they can then take that, let's say it's like the legitimate public key of the bank, and now Alice takes that to the blockchain, the distributed ledger, and just verifies, does the signature match basically. So moving forward, looking at the actual protocol message thread, how this works, and we'll give you some examples of these. But from a high level, what we have here is we have personal financial information, or we call them PFI 1, 2, and 3. These could be banks, it could be government institutions that have silos of data, right? So Alice is able, and obviously these PFIs have their own nodes and they're participating in this decentralized web of nodes. But Alice has her own, remote DWN nodes and Alice local nodes. So now we have, they're all participating. They're missing, the link here is these DWNs, right, that you have. So what happens is that Alice basically sends, she has her own TBDEX aware app or decentralized web app that knows the DIDs of various of these PFIs. So it knows about these 3 PFIs and basically sends them an ask message to initiate an exchange. So it says, okay, I want to engage with these 3 types, whether it's a government, a bank, or another type of institution. So the PFI replies back to Alice's asks via some bid message, sends back Alice to the web, basically sending back, this is who I am, this is my public key, and you can verify it in the distributed ledger. So what this does is allows for a thread messaging between these exchanges to exchange data basically in a secure, decentralized way. And this runs on top of a substrate of DIDs, decentralized web nodes. This is basically the protocol that it's being developed, and a standard hopefully will emerge for Web 5.0. An example, just to get it more, be able to more palatable, and it's this idea of Web 5.0. You have Alice's remote DWN. In this case, we all know about Spotify. We keep our music, and Block has developed a new product called Tidal. So there's multiple out there, but let's say the Tidal is just an equivalent of Spotify, right? So what happens is Spotify secures the ability to write some kind of message playlist of Alice's and sends it over to these decentralized web of nodes and just posted it out. This is this distributed ledger puts that playlist, music playlist out there. It's encrypted, and only Alice can get to that playlist, or at least the playlist is there, right? So it's kind of like stored in this decentralized web. Alice then moves into Tidal and says, you know what? I want to get that playlist that I have on Spotify and bring it into my Tidal account, right? So Tidal, which previously secured the ability for Alice's playlist and entries, can read the entry of Spotify that was added before. So in other words, it moves into the idea that why do we have to recreate these playlists over and over, and the tedious process of import exports, hoping that the playlist gets there. So this is a common problem that most of these people, that's why people don't move from Spotify to another application, or move from one application to Microsoft to Google, because this painful process so we just don't create multiple playlists, for example. Another example that we have is, in this case we have Alice again with her WDN, and Alice has to interact now with a hotel, an airline, and a car rental. So it's kind of like, wow, you got three. It's very typical to what most of the applications that we have. So Alice basically grants her hotel, her airline, and rental car provider to apply their reservation, basically that music playlist, for example, but in this case the reservation objects, to her collection of DWN. So it goes into her control of data, right? So now she has that there, and she says, you know what, I'm gonna go ahead and Alice then can grant any app that she chooses. So any reservation hotel app, whether it's all together or individually, her ticket and trip data that she has in her own data. So this gets sent to all the airlines. So now you don't have to, again, set up a trip. You plan for a trip and you have to set it up on all these different platforms. So it's kind of repetitive. So this eliminates that repetitive part. And the travel apps then can engage and also talk to, let me see what Alice's trip is all about, and bring that up. So your preferences, tickets, reservations, and other travel data are scattered across 100 different hotels, airlines, and travel apps, etc. So that's a massive problem. So by doing this DID and decentralized web nodes, you can unite all these flows and experiences much better. So those are very valid, two examples right there that gives you this ability. So the idea behind Web 5.0 is a decentralized web platform that enables developers to leverage decentralized identifiers, verifiable credentials, and decentralized web nodes to write a decentralized web apps. Basically returning the ownership, going back to returning the ownership control to the identity data to individuals. That's the key here. So question is, we're building an app platform, and the answer is they've always done it. We've always been doing this. This is part of the evolution of the internet. All right, that does it. Thank you for attending, being here at this webinar. I hope you enjoyed it, and stay tuned for more to come. Thank you.